Hello everyone. Today we will look at the properties of whole numbers. So, what is our objective today? We will be able to understand and use the different properties of whole numbers. Why are we doing this? We are doing this because this will help us understand numbers better. It will also make our calculations easy. First, what are whole numbers? Whole numbers start from 0 and increase by 1. So 0, 1, 2, 3, 4 and as far as you can count, that is a whole number. We already learned that natural numbers start from 1 and goes all the way up to as far as you can count. What is the property of a whole number? The property means that it is the nature or characteristic or trait or attribute of the whole number. So what do these mean? So for example, if I ask you, what is the property of a human being? You will say a human being has two legs, they have 2 ears, 2 eyes, one nose, and human beings have a brain, human beings can think, human beings get hungry, human beings get angry. So these are all properties of a human being. Similarly, we are going to look at the property of whole numbers. Let us look at the world of whole numbers. What is in this world? So, whole number starts from 0 and it goes all the way up till you can count. These are whole numbers. So, what are not whole numbers? Fractions. You must have seen them. Half, 1/4, etc. Decimal numbers. For example, 0.5, 22.6. So, we can see a decimal number that is also not a whole number. And they have the negative numbers -1, -10, -200. They are on the left side of the 0 on the number line. So these are also not whole numbers. So we are going to look only at whole numbers today. First, we will look at the closure property. What is the closure property? The closure property of addition is when we add two or more whole numbers, the answer is also a whole number. For example, 6 plus 17 is 23. 18 plus 200 plus 10 is 228. We can add as many whole numbers as possible, but the answer will always be a whole number. So, when we add two numbers or two or more numbers from the world of whole numbers, the answer is also inside the world of whole numbers. Similarly, for multiplication, when we multiply two or more whole numbers, the answer is also a whole number. So here are some examples. 5 multiplied by 7 is 35. 5, 7 and 35 are all whole numbers. Similarly, 2 multiplied by 9 multiplied by 6 is 108. All the four numbers here are whole numbers. So that is what the closure property means. The closure property of addition and multiplication means that when we add or multiply two or more whole numbers, the answer is also a whole number. But what happens if we subtract or divide a number? Will they always be whole numbers? Subtracting two whole numbers may not always give a whole number. For example, if I subtract 6 from 8, I will get 2. But what if I subtract 8 from 6? Will it be a whole number? Try drawing it on the number line. You will see that the answer is -2. And -2 is outside the world of whole numbers. What happens if we divide? Dividing a whole number by another whole number may not always give a whole number. So, if I divide 24 by 2, we learned in the rules of divisibility that if a number is even and we divide it by 2, then the remainder will be 0. But here we can see 25 is not an even number. 5 is not an even number. So 25 is not divisible by 2 and we will not get the answer as a whole number. We will then continue looking at the property of a whole number. Second one is identity. If we add 0 to a whole number, it gives us the same whole number. Example, 25 plus 0 is 25. If we multiply 0 to a whole number, the answer is 0. So 8 multiplied by 0 is 0. If we multiply 1 to a whole number, we get the same whole number. So 6 multiplied by 1 is 6. So these are the properties of identity. Next, we will look at what happens when we divide a whole number by 0. We say it is undefined. So suppose you want to distribute chocolates in class on your birthday. You come to school and see it is a holiday. So there are no students in class, which means there are 0 students. So can you distribute the chocolates between 0 students? No, you cannot. It is not possible, right? So if there are 15 students in the class, then I can divide 30 chocolates and each one of them will get 2 chocolates. We found this by dividing 30 by 15. But if you want to divide 30 chocolates between 0 people, we are dividing 30 by 0. And this does not have a meaning. And we say it is undefined. Next, we will look at the commutative property of whole number. What is this? When we add 10, 5 and 6, if we do 10 plus 5 plus 6, we get the same answer as 5 plus 6 plus 10. Multiplication. When we multiply 6, 7 and 2, we get the same answer when we multiply 2, 7 and 6. So what do we see? Changing the position of the numbers in addition or multiplication does not change the answer. Okay? But what happens when we are subtracting? Is 10 minus 6 same as 6 minus 10? You can check on the number line. The answer is 4 for 10 minus 6 and minus 4 on 6 minus 10. So the numbers are not the same. We get different answers. Similarly, when we divide 10 by 5, we get the answer as 2. But when we divide 5 by 10, we get the answer as 0.5. So, if we change the positions of the numbers in a subtraction or a division, we do not get the same answer. But if we change the positions of a number in an addition or a multiplication, we get the same answer. This is called the commutative property of addition and multiplication. Next, we will look at the associative property. We add 10 plus 5 plus 6. If we add 10 plus 5 first to get 15 and after that we add 6 to it, we get the answer as 21. But if we add 10 to 6 first to get 16 and then we add 5 to it, we still get the answer as 21. Similarly for multiplication, if we multiply 6, 7 and 2, first multiply 6 by 7, we get 42. Then multiply 42 by 2, we get 84. Then if we try it a different way, we first multiply 7 by 2, we get 14. Then we multiply 14 by 6 and we get 84. So the answer is still the same. So what do we see here? It does not matter which part of the addition we are doing first. We will still get the same answer. Similarly for multiplication, it does not matter which part of the multiplication we are doing first. We will still get the same answer. So this is called the associative property of addition and multiplication. In addition and multiplication, it does not matter which numbers we add first or multiply first. Answer is the same. But it does not happen for subtraction or division. You can try working with some examples and see if this is true. Finally, where can we use these properties? We will use the associative and the commutative properties of addition and multiplication. First, we will try to add 25, 7 and 5. So how do we normally do it? We start adding from the left. 25 plus 7 is 32. 32 plus 5 is 37. But can we do it in an easier way? What if we add 25 with 5 first? Isn't it easier? We get 30. And then we add 30 with 7. It is 37. So which one was easier? Wasn't doing it the second way easier than the first? So here we have used the associative and the commutative properties of addition to make addition easier for us. We will then look at the multiplication. 5 multiplied by 7 multiplied by 2. So we can do it by multiplying it from the left. 5 multiplied by 7 is 35. Multiplied by 2 is 70. But if we do like this, we first multiply 5 with 2 to get 10. And then we multiply 7 with 10. It is 70. Which one was easier? So sometimes when we have a number for which we know the tables, then it is much easier to do that part of the multiplication first and then do the second part of the multiplication. So again, we can use the associative and commutative properties of multiplication to make multiplication easy.